Right? My dear children, from my fourth video, I explained you the sp3 hybridization of carbon atom. So the carbon atom has three types of hybridizations. I explained you the first type, sp3 hybridization. Do you remember? After the sp3 hybridization, four identical orbitals are formed. All are identical, shape and energy. So these identical orbitals are arranged around the nucleus of carbon atom, like this. What is this arrangement? What is this arrangement? So all are identical. This arrangement is tetrahedral arrangement. So now you can see there are four triangular faces. Around three faces, base as the other face. There are four triangular faces of the arrangement. It is the tetrahedral arrangement. When these orbitals are arranged like this, carbon atoms, hydrogen atoms come and overlap with, this is the sp3 hybridized orbital. It has an electron. This is the hydrogen atom. It has a spherical orbital and one electron. These two electrons are shared here. That type of arrangement, combination is named as the linear overlapping. Linear overlapping. Thus formed a covalent bond. Similarly, other carbon atoms are joined with the linear overlapping, forming four covalent bonds, like this. Four covalent bonds. So this is the final molecule. This is the molecule we explained as CH4. CH4. Methane. That methane molecule has the shape tetrahedral. And the carbon has four identical bonds. All are sigma covalent bonds. So it is clear that after the sp3 hybridization, carbon forms covalent bond. How many covalent bonds? Four covalent bonds. All are sigma covalent bonds. Right? Today, I am going to explain the other type of hybridization of the carbon atom. Right? We'll go through the initial step. Do you remember? This is the energy level diagram. So 2s orbital, it is spherical. It has two electrons. So this is the 2p energy level, little above. So the 2p energy level has dumbbell shape, three orbitals. All are dumbbell shape. This is the shape of the p orbitals. Then what is the configuration? 2s2, 2s2, 2p2. It is a ground state. Do you remember ground state? The carbon atom is at rest. Ground state. So 1, 2 at the ground state, 3p orbitals, only 2 are having one electron in each, one is empty. This is the ground state configuration. I was explaining you that configuration is unable to form four covalent bonds because it has only two electrons for the sharing procedure. Then it becomes excited state. Excited state. How? The one electron of the 2s orbital transfer to the empty orbital of p energy level, dumbbell shape p orbital. Then after the excitement, there are p 3p dumbbell shape orbitals. All of they are having one electron each. Now all the orbitals are having one in each. So the 2s orbital is having now one electron only. This is the excited state. 2s1, 2p3. This is the configuration. Then after that, do we remember during the sp3 hybridization? The next step is the hybridization. These three orbitals come down little, s orbital goes little up. All the four orbitals come the common energy level. Common energy level. With the same shape. They are taking the same shape. It is the sp3 hybridization. But in this case, out of these three p orbitals, dumbbell shaped, only two are coming down. Only two. Then one remains at the original energy level. If this is the orbital, it is with the dumbbell shape orbital. The other two come down to the common energy level, forming identical two orbitals with the s orbital also here. S orbital goes to that position S. Out of the three p orbitals, only two come down p, p. So this is the sp2 hybridization. Because as a result of the hybridization, there are only three orbitals which are identical, having the same shape and same energy. These are the hybridized three orbitals. So it is clear that during the sp2 hybridization, with the s orbital, only two p orbitals are joined to give the identical orbitals. Right? So the special thing is in this type of hybridization, after the hybridization, that nucleus of carbon has only three hybridized orbitals, one unhybridized orbital. So I think you are clear that the type of sp2 hybridization. What is the difference between sp3? There are four orbitals, hybridized, identical, but in this case, sp2 hybridization, there are only three orbitals which are identical each other. Then now I will be going to explain how they arrange around the carbon nucleus. So they are arranged like this. This is the nucleus of carbon atom. These are the sp3 hybridized identical 3 orbitals. They are arranged at the same plane, giving the equal angles each other. That angle is 120. 120. At the same plane. At the same plane. These three are hybridized orbitals, sp2 hybridized orbitals. Only three. So we are the unhybridized p orbital. It has two lobes larger than the hybridized orbitals. Then I'll show you if the two lobes, the hybridized sp2 hybridized p orbitals, sp2 hybridized orbitals at the same plane, the one lobe of unhybridized orbital, the other lobe comes here. So what is the arrangement? The three orbitals are at the same plane around the nucleus. So the large unhybridized orbital lies perpendicular to that plane. Perpendicular to that plane, these are the two lobes. Perpendicular to that plane. This is unhybridized p orbital. Okay. Do you understood the arrangement? It is different with sp3 hybridized carbon atom. Then I'll draw the diagram of this arrangement. See here, if this is the nucleus of carbon atom plus positive charge, so this is one orbital, axis of the orbital, then the other axis of the other orbital. These are the three hybridized p orbitals. These are the orbitals, sp2 hybridized orbital. This is also sp2 hybridized orbital. Then the electron, the other orbital like this. Then the electron. Then these are the same plane, giving the angle 120. So, where are the unhybridized p orbital? This, it lies perpendicular to that plane, like this. I'll shade it to clear the diagram. Then this is perpendicular. They are the electron of the unhybridized p orbital. So these are sp3 hybridized orbitals. This is unhybridized p orbital. This is the arrangement of the orbital arrangement of the sp3 hybridized carbon atom. sp2 hybridized carbon atom. Sorry. sp2 hybridized carbon atom. So then, according to this arrangement, you have a problem, no? How it forms four bonds. Then you must know that hydrogen atoms do not like to form covalent bonds with unhybridized p orbitals. It is clear that. So, if you are at that idea, so you are clear. It is easy to understand how it undergoes the formation of a compound. Right? Then, H atoms come to combine with these three orbitals, as in the case of sp3 hybridized carbon atom. So only three H atoms are possible to combine with. Then what will be the final compound? CH3. Okay. So the carbon atom has the idea to fill the outermost orbital with 4 electrons. But now it is unable to complete the octet. That means this is unable to form a compound. This is unable to form a compound. Right? Then you must know that sp3 hybridized carbon atom can form compound with H atoms for the completion of octet, but sp2 hybridized carbon atom is unable to form itself a compound for the completion of octet. Then what should be done? Then after that, first of all, such sp2 hybridized carbon atom should be combined with another sp2 hybridized carbon atom. Another sp2 hybridized carbon atom before the completion of octet. Right? Then, so how it happens? See here, if there are two carbon atoms, both are sp2 hybridized carbon atoms. This is one carbon atom, this is the other one. This one also having orbital like these three orbitals which are sp2 hybridized. This is the unhybridized p orbital, electron cloud. This is the electron. The other carbon atom also having that arrangement. So what will happen? The one orbital, sp2 hybridized orbital of this carbon atom combines with the other carbon atom, forming a sigma covalent bond between these two carbon atoms. First of all, so this carbon atom also now has sp2 hybridized two orbitals, similarly as in this one, sp2. This one also having unhybridized orbital also, like this. Then these three are at the same plane. These three are at the same plane. These three are also at the same plane. If the two carbon atoms at the same plane, they are joined with sigma covalent bond. These two carbon atoms are having all the orbitals at the same plane. These three and these three also at the same plane. This bond is also formed at the same plane. Then, when they join at the same plane, it is clear that, see here, this is the one carbon atom. This is the one carbon atom. So similarly, other carbon atom also here. If these two are bonded with the same plane, the two carbon atoms come same plane with a sigma covalent bond, the large unhybridized p orbitals both are having perpendicular to that plane. So they are able to touch with laterally. They are touched with laterally. Right? These unhybridized p orbitals overlap laterally overlapping. So these are linear overlapping. The linear overlapping orbitals form sigma covalent bond, while laterally overlapping unhybridized p orbitals form phi covalent bond. Right? After the connection of these two carbon atoms with the sigma covalent bond in between the two nuclei, the laterally overlapping phi bond, there are two sp2 hybridized orbitals of this carbon atom and the other one also having sp2 hybridized two orbitals here. They combine with H atoms. S orbital. Here also same, combines with H atoms, thus forms four covalent bonds, sigma covalent bonds with four H atoms. This is the molecule. Now see here, this carbon atom has 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. Completion of the octet. This also a completed octet. 1, 2, 3, 4, 5, 6, 7, 8. So it is clear that sp2 hybridized carbon atom forms tetrahedral molecule like this, forming four sigma covalent bonds. But now you are clear that sp2 hybridized carbon atom is unable to form a compound alone. It should be combined with another carbon atom with a sigma covalent bond and phi bond. Then after that, other hybridized two orbitals are formed, sigma covalent bonds. Thus, two carbon atoms completed octet taking the stability. This compound has two carbon atoms. There's a double bond between two carbon atoms. One sigma bond, other one is phi bond. So these two are sigma covalent bonds. Other two are also sigma covalent bonds. All are at the same plane. It is clear that, but the phi bonded, these electron pair lie perpendicular to that plane. So these are the sp2 hybridized two carbon atoms, right? Then I think you are clear that the two types of hybridizations, sp3 and sp2. Today I explain you how the sp2 hybridization is occurred and how sp2 hybridized carbon atoms become to the stable configuration with the combination of other atoms forming compounds, right? Then next day I will explain more about the sp2 hybridization and taking the compounds as the examples, and I hope to explain you other type of hybridizations of carbon atom also, right? So thank you my dear children. See you from my next video. Thank you.